Welcome back, and we're just going to kind of continue working on that example. So so we still have that NEA and fat gain example in our brains, and we found the LSR line, right? And so now we're going to say, what is the estimated fat gain for any NEA change of that? And so, okay, I'm just thinking fat gain was Y, NEA change is X, so I can still compute Y hat and do the negative 0.0034 times 800 and then plus 30 or 3.5051. Okay, and I'm not going to calculate it. I'm just going to say you can punch it in a calculator and get a number. Okay, now the other question here, NEA change of the, okay, so I want to know what X is based on this Y. Okay, so, okay, now I know that, wait, this is Y, but this is Y hat. Is there a difference? Actually, yes. Okay, remember, Y hat is predicted and Y is actual. Okay, so we can't, this one I have no clue how to do because the equation for the LSR line, that's a prediction. Okay, I could, if I was so lucky, I could look at my data set and see if I had precisely 2 kilograms in my data set and I could use that observation, but I can't concretely say if you have a fat gain of 2 kilograms, this will always be your NEA change. No, everybody's different. So this one doesn't make sense. So know that if you are given a Y value and asked to predict, or a response variable value, right? Because this is a response variable, and then you're being asked to predict your explanatory variable, you can't. Okay, so beware. Okay, and actually, I fooled you on the first one too. Okay, let's take a look at the data set. So we're back looking at the Excel data, and notice how the equation of the regression line, the LSR line, extends only from the minimum value of the explanatory variable to the maximum value of the response variable. And that's always the case. So what we're doing is, you can kind of imagine we're trying to find the point, like if this were to continue, it would be about here. Oh, I don't know what that'd be, about 0.8 or so on the vertical axis. And I would like to continue that, but unfortunately, the prediction power that I have for the regression line is only valid between the minimum and the maximum of the explanatory variable. Okay, what we're trying to do right now is called extrapolation. Okay, so extrapolation is when you're trying to predict beyond the range of the explanatory variable. Okay, again, what the LSR line is it's trying to predict the value of the response variable for the range of the explanatory variables that we have. Okay, so just be careful with that. And then again, keep in mind that this is also an average prediction too. So when we're predicting outside the range, it's called extrapolation. And then actually, in the previous video, when we predicted for an NEA change of 200, right? That would have been here. That, if we're predicting within the minimum and maximum range of the explanatory, that's called interpolation. I-N-T-E-R, and that's perfectly okay. You can do that so you can do interpolation on the response variable if you're within the range of the explanatory variable, but you can't do extrapolation, generally speaking. I should say except unless you're a meteorologist and then you extrapolate all the time, and that's why when the weather isn't as they predict, they fall victim to extrapolating incorrectly. Okay, so just know extrapolation is generally not okay, but interpolation is okay. Okay, and so just beware. Okay, some other comments about the LSR line. When we're looking at the equation of the LSR line, the slope is going to vary based on the units of measurement that we use. So if we're, in one measurement we're using miles for the explanatory variable, and then we switch to feet, like completely different, and we have to, multiply by multiply or divide by 5,280, depending if it's a response or explanatory. So just beware, okay? The other thing is beware of rounding. I know all of us have a habit of rounding, and I'm just going to say when we have the equation of the trend line, use every digit, keep track of every digit. Do not round unless sapling or the instructor tells you to. Okay, so just be aware of that. I've already talked about the difference between y and y hat. Y is the actual value. Y hat is the predicted and it's actually predicted average value. Okay, I forgot to include that language. So this is actual, and this is the predicted average value. Okay, and this one you get from the LSR line exclusively. Okay, the y value, that would be from our data set. Okay, so just make a distinction between those, and honestly, if you're doing the calculation with the LSR line, writing y hat is kind of fun. When else do you get to put a hat on things other than yourself? Okay, and so in all of this, you've noticed that I've tried to carefully articulate explanatory and response variables. That is purposeful. Okay, you have to be able to distinguish between the two, and otherwise, you know, if you're trying to predict, like I said up here, you cannot predict x based on a y using your regression line. So just beware. Okay, and then just so you're aware of some of the calculations that are going on in the background, if we were to calculate the slope, okay, so the slope of the regression line, that's actually connected to the correlation of the scatter plot, okay? And then, so you can see B, the slope is equal to the correlation, and then each of these are the standard deviation in the subscript variable, so standard deviation in the y variable, and then this would be the standard deviation in x. You're not going to have to do this calculation. I just wanted it to just bring it to your awareness. Okay. One super neat thing is that when we look at the LSR line, it always goes through the what I call the centroid. Okay, and the centroid is simply the average value of x of your explanatory variable, average value of x, okay, which is x bar, the mean, and it also goes to the mean for y. So y bar is equal to the average value of y, okay? And so it doesn't show you this point specifically on any scatter plot, or on any of the scatter plots that you make in Excel, but it is a fact. Okay, so just in case there's multiple choice tests in your future, be aware of all these facts. Okay, and specifically be aware of extrapolation and interpolation.